All right. So, guys, you already know the Pythagorean Theorem, but you all know it as this. A squared plus B squared equals C squared. That's what it was taught to you as, which is wonderful, except, of course, when teachers mess with you. And it's not just teachers, it's common sense. You guys learn that, and you're like, okay, I got this thing, man. So here's my triangle. This is 3, that's 5. And you go, okay, so this must be 3 squared plus 5 squared equals C squared. And then you go, okay, that's 9 plus 25, so that's 34 equals C squared. And then you square root it, and you get a bigger number than 5. And you hand it into me and say, yep, this is the square root of 34, which is... And then I say, what? I put a question mark by it, and you run up to me with your calculator. And you say, look, square root 34, 5.8. This is 5.8. And then I say, look again. And you say, and then you walk away. Because you don't want to admit you're wrong, because you're millennials. That's okay. It's all right. So that is why I am bothered by A squared, B squared, C squared. Now, all of you are honor students, so you would not fall for something so silly as that trick. But I have taught 17 years of honors math, so here is what I like to do. Wait for it. I like to do this. A, B, C. And then I like to tell you that A is 3, B is 5, and C is what you have to find. And you all get it wrong. Because if you only know Pythagoras is A squared, B squared, C squared, what letter should this be? C. But I made it B. And I give questions like this to my honor students, and I say, I bet you guys can't do Pythagoras. And they say, yes, we can. I totally do Pythagoras. Fine, do this question. And the whole class does it wrong. So, that's why I don't like doing A squared, B squared, C squared. Because if you change the letter, kids say, Mr. Myers, I don't know how to do that. It's got different letters. So I don't do that. I like to teach it in a different way. And the way I like to teach it is using hypotenuse and legs. So the hypotenuse is... Now, what do you know about the hypotenuse? What's the first thing everybody says about the hypotenuse? What's the hypotenuse? Longest side. You got a ruler?
I do have a ruler, actually.
So everybody says it's the longest side, but if you don't have A, if you don't have measurements, and B, if you don't have a ruler, can you guarantee to me that it is the longest side? No, you cannot. So a better way to define the hypotenuse is this. It is across from the right angle. That's how you want to define it. Because then, no matter how you turn the triangle, or more importantly, whatever the triangle looks like, you can find the hypotenuse. Because it's always across from the right angle. The legs are the other two sides. And they can be used interchangeably. Okay?
Sammy said that yesterday to me. She said if you don't want the money. What? Okay.
Interchangeable. So, In this question here, you will notice I've used no A's, no B's, and no C's. Because much like saying a triangle is base times height, how you turn that triangle changes what is the base and what is the height, yes? So I don't like to use A, B, C's. I like to use leg, leg, hypotenuse. And you get to hear a story from my grade 7 days. So what I like to do is I like to do leg squared plus leg squared equals h squared. My grade 7 teacher, Mr. Bailey, taught us the Pythagorean Theorem. And Mr. Bailey taught us to remember it as the square of the hypotenuse of a right angle triangle is equal to the squares of the other two sides. And then Mr. Bailey said, if you cannot remember the name of the longest side of the triangle that is across from the right angle, it's a hypotenuse. But if you forget, you can call it a hippopotamus. That was how he reminded us. So on the tests in grade 7, Mr. Bailey wrote a question. What do you call the longest side of a right angle triangle? Could I remember the word hypotenuse? No. So what did I write on my test? Hippopotamus. What did Mr. Bailey mark it as? Wrong. I know. Mr. Bailey told us to remember it as hippopotamus, which is why, ladies and gentlemen, I never do that. I do not say remember things with anything but what they are actually called. All your little tricks of counting on your fingers to multiply to 9, I just multiply to 9.
I count this is my favorite trick.
You don't know that trick?
Max, you know it.
You know it, Max. 10, right? So what's 9 times 1? 9, right? No, it doesn't work with 9. I can't remember how it works.
Just do it works 9 times 7.
Yes, that's what it is.
63. So it's like 5,
Yeah.
6, 1, 2, 3.
Yeah.
Or 9 times.
You put down your sixth finger,
Yeah.
starting here, 1, 2, 3, 4, 5, 6. So 9 times 7, you put down your 7th finger. Then it's 1, 2, 3, 4, 5, 6. 1, 2, 3.
So 63.
Which is silly because you could just, by the time I figured out that trick,
that's way
I've already multiplied 9 times 7 1,000 times.
The easiest
No,
multiplication
that's
set
the
as
only
well.
way I
The way
know
I
it.
remember it is because 9 times 7, that means it has to be 6, and I just memorized what kind of
Anyways. No. So
it should be 9 times 4.
So this question here is what? You've got the two examples of the Pythagorean theorem here. This one is adding. This one is subtracting. Why?
Because you already have the wrong side of it.
Right. Okay, you add when you need the hypotenuse, and you subtract when you need a leg. The next mistake every kid makes is you forget to square root at the end. Or worse, you square root but forget to hit the equal sign. Because some of you have a calculator that as soon as you hit square root, it changes, right? And you think that's the answer. All right? And then you hand that in to me. On a final exam a few years ago, I gave the kids this question. This was a lake. I told them that there was a cabin here, a store here, and a dock there that made a right angle triangle. I asked them how far it was from the cabin to the dock.
That is a sick question.
Okay? They knew how far this was. This was like 3. This was like 1.7. And they did the math, and they told me that this lake that is only 3 long and 1.7 that way, if you were to go diagonally, was 12. And they all handed that in to me. Not all, but like 20 of my students told me that this miracle lake that is 1 by 3 becomes 12 if you walk across it. Why did you do that, kids? Same answer as always. My calculator said so. Did you maybe forget to say to your calculator, hey, calculator, could you square root there at the end? Doesn't work. Your calculator is not Siri. So, what is this one? What is this one? What is this one? 8 squared plus 15 squared equals h squared. I like to just square root right there. Now, can you punch that into your calculator? One shot. See if you can. Because you know the answer is 17. But see if you can get it in one go. And if you can get this in one go, try this one in one go. It's going to be the square root of what? 12 squared. What? Minus 8 squared. The miracle triangle that's 15 by 8, but 289 here. What did you forget to do?
I got 17.
Square root.
Oh, square root.
So, Fatima, you're going to walk 15 steps this way, 8 steps this way, miraculously 289 steps away from me? I know. Of course I do. Of course you can. There is a typo. That's supposed to say 25 feet.
Okay.
Go.
Thank you.
So what's this one?
17.
This one was 17. Was everybody able to get it in one go on their calculator?
I did.
How'd you get it in one go on your calculator? If you had a backwards calculator, you went 8 squared plus 15 squared equals square root, yes? And if you have a forwards calculator, you did square root, bracket, close the brackets, then hit equals. Right? What's this one? Yeah, but what's the answer? Yeah, but what's the answer? I know you know how to do it. What's the answer? 8.94. Everybody cool? It's also the square root of 80. Everybody cool? Cool as a cucumber. All right. Okay. Looking at 2a, what are you going to do to find x?
Well, first you have to find.
Go. Find x.
Yo, listen.
The bottom one, I'm not sure what you're asking me. This? Could you? Could you? Is there anything wrong? John says, couldn't we just do that? Is that okay? What assumption is John making if he's going to do that? Because I'm not saying he's right or wrong.
The other side is also 20.
What assumption is John making? He's assuming these are the same, yes? He's also making an assumption that this is what? What assumption is John making? That is what angle? 90. Can he make that assumption? Is that allowed? No. What's the only thing that you know about this? That this is 90, correct? Okay, so now, do I like what John did adding a line there? Is that okay?
I'd say so.
We've done that in the past, haven't we? If John drops that line right down there, right? Now, could he find x feasibly? What do you need before you can get x here? I'm asking you guys, like,
The hypotenuse of the other triangle.
you need this, don't you?
Yes.
If you have that, can you find x? Okay. So really the point I'm trying to make is sometimes you have to find out something that you don't need to find out, or that isn't asked for, to find out what you need, right? So if you knew this, this becomes super easy, correct? But right now, that's really hard, yeah? Because of a lot of things, right? You're not allowed to make this assumption, are you? Okay. So is there something else I could do to find that side? John says drop that right down there, right? If this is 90, then this would be how long? 10, correct? Everyone agree? If John drops down that line, what does that make this angle right here? Makes it a right angle, right? If John drops that down, yeah? Now, do we know he has split this in half? Do we know that? No. Right? But we do know that we have made a 90-degree triangle, don't we? So could we use that to find this? If we know that, do we know that? How?
It would be the same if it's if like both like the
No,
other side.
it wouldn't be the same.
It wouldn't.
Not necessarily. Jenna, how do we know?
Take that length and subtract it from 35.
Right, this would be 35 minus O, wouldn't it? And if all of these are 90, then this would be 35 minus O, wouldn't it? Everybody with me? Picking up what I'm putting down? That is what this unit is about. You have to do stuff with other parts of the shape to find what you need. It's called indirect measurement. Everybody cool? So, knowing what we know, if we're happy with this, we drop down the same line, right? Okay. What would we do? What's this going to be? Now, don't try not to give me an answer. Try to tell me what math you're going to do there. That is going to be the square root of what? Pardon? What's this section going to be? Square root of 300, because it is square root of 20 squared minus 10 squared, yes? So that's going to be the square root of 300. Why have I not gone to my calculator yet? I don't need to. Every time I touch my calculator, there's a chance to hit the wrong button, yeah? Okay, so that makes this automatically what? What is this part now? Again, don't tell me a number. Tell me what it is. 35 minus root 300, yes? And if this is a square, right, which it has to be, why? Because I made this line, I know that's 90. So what's this one have to be? 90. That's 90. That's 90. So these guys have to be 90. So this must transfer right up to there, yes? Cool? Now I'm going to go to my calculator. Because I know that's 35 minus square root of 300. Everybody cool? Okay, you guys try the next one. Yo.
Did you say it was
you're not assuming anymore because this line you drew and you knew that's 90. Right?
Yeah.
So if this is 90, right?
Yeah.
All right. So what's different here? What's different here?
We're trying to find out the very bottom.
You're trying to find this. So what do you know?
We know
What do you need to find x?
you need the hypotenuse of the right triangle.
If you know that, you're in business. If what? Can you find this green line? How? What is that green line? 20 squared plus 10 squared, right? So that is the square root of 400 plus 100, which is the square root of 500, right? So what is the square root of 500? 22.4. It's not a pretty number, right? So let's just leave it as square root of 500 for right now. Except you know, so now you know that square root of 500, that's 25. Do you know anything about this angle here? What do you know about it? How? You're finding the hypotenuse over here. This triangle is a right triangle. Do you know anything about this angle? Do you? Do you know anything about this angle? You can guess that it's 90, but you know. Yes or no? So how are we going to find x here? You guys said all we need are the two sides, right? Can I solve this without making... Oh.
Okay, start off. You got the line down the middle.
Okay.
And then because you know that line is 20 centimeters.
Mm-hmm.
So if you do like Pythagorean for that side and then you do Pythagorean for the other side and just add those two.
Look at you. Is she right?
I don't know.
It's tricky though, isn't it, Max? Because what you all wanted to do, I bet, because it's what most people want to do, is say that's 90. Right? Right? Because if you say that's 90, you just Pythagoras these two sides, you get the x, don't you? But you're not allowed to say that's 90, are you? You can only do what you know. Right? So dropping this line down, which you know to be 20 because you put it there. Now you can Pythagoras for this, which is the root of 500 squared minus 400, right? And this side is root 25, the root of 25 squared minus 20 squared, right? Then what are you going to do with both of them? Add them together. So let's try and do that on our calculator. So what do we know this is? This is the square root of the root of 500 squared minus 20 squared. So square root of 500 squared is what? But then square that. It's 500, right? Everybody knows that, yeah? So this is 500 minus 400. Square root of 100. So how long is that? 10. Now come over to here. What's this side? Square root of what? 25 squared minus 20 squared, which is the square root of 225, which is 15. And what do I get? 25. Everybody cool? Okay.
X is 25.
In the bottom one, yes. Now, the next thing that becomes important here is you have to remember looks don't matter. Okay? You use the information that you have. Cool? Cool? Okay. So everybody remembers Pythagoras, yes? I don't need to go any further with Pythagoras? Good. Okay, this next part is kind of important. Yes. Yes. All right. Guys, this next part, and I'm not giving you any work tonight, so it's no big deal that we're going to go right up to the bell. How you read these triangles is very important. Okay? So there's a couple of things you need to know. Corners have a special name. They are called a vertex. If there's more than one, they are vertices. And vertices are angles. So this triangle has 3 angles, and they are named with caps. So this triangle ABC. Okay? Now, work with me here. This angle has 3 names that are interchangeable. It is angle C, because that's the vertex. Cool? It is also angle BCA, because I go from B to C to A. Got it? It is also angle ACB. Does everybody know that? You all know that from the past, yeah? So you can name all 3 of these angles. That's cool. I don't need to go any further with that. Good. Okay. Corners are named with caps. Shapes are named by vertices in order. So if I name this triangle ABC, I'm going from down here, up, down, and back. Or, sorry, ABC. I went alphabetical. I went along the bottom, then up, right? So what would be the name of this triangle down here? If this guy is named ABC, what is this guy's name? FED. This guy is triangle FED. Why? Because you got to go in the same order. Everybody cool with that? Yeah? All right. So, because we measure or we name in the same order. Okay, now, what else is there on a triangle other than angles? Sides. Sides are named 2 ways as 2 ways. This side, what's one name for this side? This is AC. What's another name for this side? CA. Those are the ones you already know. There's a third way to name them. In the 10th grade, we like to name our sides by their opposite angle. By their opposite angle. Opposite in trig always means across. And we name them named with lowercase. So, there's B. I go across the triangle and I hit a side. This side gets the name little b. Okay? So what does this side get? little c, and what does this side get? Little a. Is everybody cool with that? Okay, so now name the big triangle sides. What is this guy? Little d. What's this guy? Little e. What's this guy? Little f. Got it? Everybody cool? Okay, your job right now is, if you have one, please measure side A, B, C, and D, E, F. If you have a ruler, measure it. Somebody measure it so we can give that number to everybody else. Somebody's got a ruler. Somebody just measure them, please. I can't measure it because it's going to be a different number because I have it on my computer screen, right? I need one of you guys to measure these.
We're measuring it.
Thank you.
We're doing this one first. Here, angle A.
No, not angle. The side. Measure the side. You don't have a protractor.
Are we going in metric or in period? 9 centimeters.
9 centimeters for side which? Little c?
Little c.
Little c, Sam has it 9 centimeters.
Sam?
Or Max, sorry. 9 centimeters. Who has a measurement for little b? 7? And who's got a measurement for little a? 4.5? Cool. What do we have for D, E, and F?
Little d.
Lil D.
I'd give it 14 centimeters.
You're going to give it 14? Cool in the gang. Lil E? Little E?
Oh, you want me to say it? I thought it was someone else's too. 11.5.
11.5. And little F? 7. All right, everybody cool? Okay. Now, rather than get you to get out protractors, I'm going to tell you that the angles are all the same. Okay? Angle A equals angle F, B equals E, and C equals D. Okay? Now, you guys already know this, I hope. If I take the side length of angle A, side A, and the side length of F, and I divide them, I'm going to get a fraction, yes? So what is A? It was 4.5 divided by F, 7. Why am I comparing A to F?
That's like the side.
Because they're in the same relative location, yes? And B and E compares with what? 7 over 11.5, yes? And C and D gets me 9 over 14. Now, what will you find when you do this math? What is 4.5 divided by 7? 0.64. What is 7 divided by 11.5? 0.61. What is 9 divided by 14? 0.64. Now, you guys are smart kids. What do you notice? They're all pretty darn close to the same, aren't they? Should they be exactly the same? Yeah, they would be. Why? Why aren't they exactly the same? What went wrong? Measurement, right? Because we're measuring with inaccurate devices, right? This tells us what? This tells us that if I take a triangle and I make a copy of it, that's not going to work. It's going to blow up in my face. It didn't.
It's like a closing.
It's the exact same triangle, yes? And you know this. Please let go. Please let go of the triangle. Please. Please let go of the triangle. Please. 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 Hey, it let go of the triangle. All right. If you know this side is 4.5, and you know this side is 11 or 7, and you know this side is 11.5, you can then use that to find this side. Why? You did this last year.
Remember this from last year?
Why are you able to do that? It's similar triangles, right? Because what has changed here? Have the angles changed at all? No. So the triangle, that's why your computer is able to do what I just did, why I'm able to stretch it out that way. Because these aren't changing. How big could I make this triangle? Infinitely. Because these angles aren't changing, are they? Angles do not change by the length of the side. Everybody understand? Which is why this is how we build stuff. When we built this school, did they build the school somewhere, take it apart and bring it here and put it back together? No. They drew it on a piece of paper. Why? Because that angle between the ceiling and the wall, no matter how big I make it, is still the same angle. Understand? This is where we get scale drawings. This is where we get maps. This is where we get models. Now, nowadays, computers take care of this for us, yes? But you still got to know how to apply it to the situation. Everybody cool? All right. So that is where we're going to stop now. What you need to take away from today is, 1, you have a test on Wednesday. 2, what you need to take away from today in the unit that we're going to be working on tomorrow is this. Size doesn't affect the angles. Okay? Length of side does nothing to angles. That's what you need to remember for going forward in trigonometry. Okay? Okay. You've got the rest of the period off. Because you have no homework tonight.
Yes, we do.
Except to be ready for your tests on Wednesday. Tomorrow we begin trigonometry.